Welcome to the presentation given by UPass Education. So today we're going to talk about permutations and combinations. Well, what's the difference between permutations and combinations? Well, it's just a matter of a question of does order matter or not? So to illustrate this, let's think about this example. So let's say we have 3 balls with 3 numbers on them. So each ball is numbered 1, 2, and 3. So what permutation means is that we need to choose 2 balls from the 3 and line them up. In this case, order matters. So imagine what kind of permutations we will have. First possibility is we will have the 2 balls numbered 1 and 2. Secondly, we will have the 2 balls numbered 1 and 3. We also have the balls numbered 2, 1 and 2, 3. And similarly, 3, 1 and 3, 2. So this is permutation. We choose the 2 from the 3 and line them up. So we have 6 possibilities in total. Now let's look at combination. Well, let's say we grab 2 balls from the 3 and order does not matter. So if we grab balls number 1 and number 2 or number 2 and number 1, we look at them as the same. So we can have 3 combinations in this case. 1, 2 or 2, 1, 1, 3 or 3, 1, or 2, 3 or 3, 2. Therefore, permutations and combinations are not the same. So this is a basic idea about permutations and combinations. So when we come to calculate the permutations, we're really calculating how many possible choices we have. So let's use the previous example. We have the 3 balls, line them up in 2 boxes. In this case, again, order matters. So let's think about this. What's the possibility of the number on the ball in the first box? So we have 3 balls numbered 1, 2, and 3. So in the first box, we can either have 1, 2, or 3. So we have 3 possibilities. And the next step is looking at the second box. So when we're looking at the second box, keep in mind that the first box is chosen. So once we have already chosen 1 from the 3 balls, we have 2 balls left. So whatever we chose for the first box, we have 2 possibilities left for the second box. So for each of the balls chosen in the first box, we have 2 possibilities in the second box. Well, how many possibilities do we have in total? Let's think about this. For the first box, we have 3 possibilities. And for the second box, we have 2 possibilities for every and each of the possibility in the first box. So in total, we have 3 times 2, which is 6 possibilities. Now, let's continue with a more quote-unquote complex example. Let's say we have more balls now, and we have 5 balls, and each of them numbered 1, 2, 3, 4, and 5. And we need to grab 3 of them and line them up in 3 boxes. In this case, again, order matters. So similarly, when we are trying to choose a ball for the first box, we can choose any of the 5. So there are 5 possible outcomes in the first box. When we come to the second box, since one of the outcomes is already chosen, we have 4 balls left. So we can have 4 possible outcomes in the second box. And in the third box, since the first and second box are already chosen, so we have 3 outcomes possible. So we have 5 times 4 times 3, which is 60 possible outcomes. Then we say the permutations in this case is 60. Now let's look at a more general example. Let's say we have n balls, line them up in r boxes, and order matters in this case. Now let's look at the first box. Again, we have n possible outcomes. Because none of the ball is chosen, we can choose any one of them. In the second box, since one of them is already chosen, we have n-1 possibilities. And so and so. In the last box, we have n-r plus 1 possibilities. A lot of people are thinking about this. Why do we have the plus 1 there? Because we have r balls in total. So n-r plus 1, n-r plus 2, all the way to n. If you count it, that's going to be r balls in total. So let's think about this. If n equals 5 in the previous example and r equals 3, we have 5 times 4 times 3. So the last box is 3. Well, keep in mind that n is 5 and r is 3. So 5 minus 3 is 2. But our last box is 3. So it should be 2 plus 1. So in this case, we have n times n minus 1 and all the way to n minus r plus 1. So total number of choices in what we call permutations is n times n minus 1 times n minus 2 times all the way to n minus r plus 1. So if we write this expression as n times n minus 1 times n minus 2 times all the way to n minus r plus 1 divided by 1 and multiply by the following expression, we will get the total number of this huge so-called formalized expressions. And if you look at the denominator, it's really n factorial. And when you look at the divisor, it's n minus r. And when you look at the divisor, it's n minus r factorial. So if we give this permutation a notation of NPR, then we will have NPR equals n factorial over n minus r factorial. So that's permutation. Now we come to combinations. There are two approaches to understand this combination, and I'll show you the easier approach. So the easier approach is from permutations. So think about this. What's the difference between combinations and permutations? It's just that order doesn't matter. So recall the previous example. In a total of n balls, pick out r balls and then line them up in r boxes. So we have NPR equals n factorial divided by n minus r factorial. So now, if we don't want to line them up, we just grab a group of them. So order matters. So order doesn't really matter. So any order of the r balls chosen are treated as the same combination. So in this way, we have the possible outcomes of permutation divided by the possible number of permutations in r balls, which is divided by r times r minus 1 all the way till 3, 2, and 1, which is r factorial. So in this case, we have NCR equals NPR divided by r factorial, which is really n factorial divided by r factorial times n minus r factorial. There you have it. That's combination. So for more detailed explanations, you can attend one of our classes, and there'll be a more thorough explanation for permutations, combinations, and all the other chapters in Math 30-1.